So you've looked at the general equations. Now there's something known as linear operators, which just makes us simplify the way of proceeding with our solutions. So I'm just going to give you a quick introduction to linear operators, just what they are. In linear algebra, we've seen what linear operators were, right? So it's basically what happens when you multiply an operator with a constant and what happens when you multiply a linear function. When you add two linear functions. That's basically the linear operators. For a linear operator, let's say y is our function that's being operated by the L over here. So if you're multiplying that by C, then the property says that C can just come out and you can operate y linearly and just multiply it with the constant C. And when you're adding two operators, let's say y1 and y2, then it is just the same as operating the first function y1 and operating the second function y2 and simply just adding them up. So these are the properties for linear operators. Now let's just consider, for example, linear operator y of t, okay, which is given by y double prime of t plus p of t times y prime plus q of t times y. Let's say this is a linear operator. So I'm taking the entire second order differential equation and I'm using it for the linear operator. Let's say linear operations like multiplying by a constant or adding to two functions. So we can use that. So I'm just going to do a quick derivation and show that it's possible. So if I'm doing the operation on, let's say, c1 times y1 of t plus c2 times y2 of t, where y1 and y2 would be y1 double prime of t plus p of t y1 prime of t plus q of t times y. So you understand how it works, right? If that is the case, what would we get? Okay. So over here we would get, if you're operating on this one, c1 y1 plus c2 y2 double prime plus p of t times c1 y1 plus c2 y2's prime, the first derivative, plus q of t times c1 y1 plus c2 y2. Okay, now I'm going to differentiate this. So when I'm differentiating it twice, I'll get c1 times y1 double prime plus c2 times y2 double prime, because c1 and c2 are constants, right? So plus p of t times c1 y1 prime plus c2 y2 prime, correct? And then plus q of t, and then that would just stay because I'm not differentiating anything. Now I'm just going to rearrange the terms and collect all the c1s together and c2s together. So if I take c1 out, I'll get y1 double prime plus p of t times y1 prime plus q of t times y1, right? And then now I'm collecting all the c2. So I'll get y2 double prime plus p of t times y2 prime plus q of t times y2. And this is how we defined y as, right? So this was the linear operator on y. So this would become c1 times the linear operator on y1 plus c2 times the linear operator on y2, right? So we have just proved these two things using a general second order ordinary differential equation. So this is the basics of linear operators. When you think you have to like make it simplified, or if you're seeing something indirectly of this form with two differential equations, then this is a very easy way to do it. Okay, thank you for watching.